I'm gonna click the button then.
Let me give him the like the zoom in one. Was everybody able to get SQL Server Management Studio up and running during the break? Almost everybody. All right. If anybody still doesn't have like a working copy of that up and running, let me know. And we'll work on that.
It's just going to take a bit.
Still doing updates, yeah. Did the service packs come down?
Let's see. I think I saw a couple in here. Service pack. Well, that's what offers.
I think you just need 1 and 2 just for the main operating system. Then you should be good to go. A lot of those ones that say like recommended or something, you can probably skip over. But it ought to do like 1 and stuff. It'll make you middle of 2 and it'll make her 2.
So I feel like I have a table here that's got that key thing with the customer ID.
Yeah.
And then when I select from the table, it doesn't display that column. So this is it. Customer name.
That asterisk is there, which means you never click save.
Oh, good. Oh, right. I couldn't fix this problem. That's all. Okay, that was in tools, wasn't it?
We need to check. So if we made a key, that's good. Did you do the identity specification then? Let's scroll down till we see
okay. Let me check and see if that
make that a yes.
every time. If it does,
What's that do?
Yeah.
How do I do that?
Double click it, it'll be.
Hey Derek, are you going to, like I noticed you've been doing Alpha Bravo, like kind of creating a new database every time. Are you going to continue that? Okay, cool. So if anybody's behind, they can just start fresh with like the new stuff you're doing?
Yeah.
Okay.
I'm not using database names for anything. If they can call them whenever they want.
No, I know.
I'm going to keep going. I'll be doing Delta next.
Like a new one. Okay.
Yep.
Cool.
Oh, I see what you're saying.
That's perfect.
We'll
So
building on it.
people that hadn't installed, hadn't gotten it installed until now, like we're going to be starting kind of fresh with a new example, right?
Right, yeah,
okay,
we are. And I did that on purpose. I actually want them to create lots of tables. But it's actually the same table every time, so it's kind of easy.
Yeah.
It's on purpose.
So that was something like, it was brought up, we had to go in the options and turn on something.
It's already been done, so you can close this.
Okay.
And are you double clicking here?
Yeah.
I would, this is not connected. Is there any reason to believe that you closed and reopened SSMS or disconnected the connection, reconnected it?
The connection to the internet definitely happened.
Are they ready to go?
I think so. I'll put out the call, see if they're ready.
All right.
I got disconnected from the internet, maybe that because of the VCU thing.
Maybe, yeah.
Something to do about that.
Try executing again.
Harper, do you want me to start? Or do you want me to wait till you get an okay?
You can go ahead and start the stream.
The stream's already started.
Okay, give me 1 more second when they confirm. Yeah, your select star, that SQL isn't completed, so it won't run.
So
you gotta finish like your statement.
So I kind of got confused. This is customer names, this is customer names, this is that.
You start with the fresh database and something. So you just start with the bottom.
Yeah, bravo.
1 minute? No problem.
I think mine's just a little different because it's 2014, but it says the management tools. That's just like this, right? And it's completed, so okay, good. Looks like it.
Maybe we just want to close out that whole thing there.
Okay, we'll go ahead and get started. Hopefully our friends will join us. So, when we left off with our adventures, we just had added a new primary key. Remember, we did two things. We made it a clustering key, which allowed us to do quick seeks on it. It ordered it in the database and gave us a nice, unique handle for any given row. That was good. And we made it identity 1-1, so it would automatically create those numbers for us. We didn't have to. We could have actually done one or the other, but in most products, you do all of that on that same one column. There are some differences, but most teams will always do those two things on that primary key. In fact, it's done so often, many people don't know that it's two separate features because it's done so often together. So what I want to do, I'm going to actually do a new database, primarily because we have a few people who have just successfully installed a SQL Server. So I'm going to start, I'm going to do a Delta database, and we're going to create a new table in it that's, and you can go ahead and follow along, that's very similar to the table we already had, but we're going to give it that key right from the beginning. So I'm going to start right off with customer ID. Oops. Let's get the capitalization a little bit nicer. There we go. It'll be an int. I hit spacebar to make it not null. I'm going to immediately make it a key and identity 1-1, just like we saw before. I'm double clicking on this identity specification in case you're wondering what to do with it, although it's not working.
I think if you open it up, if you pop that thing back open, identity specification, then the next, that one's selected.
That's the one I'm double clicking. I don't use the designer very much, so you're seeing me stumble with it. So I had to expand the identity specification, thank you Harper, and then double clicked that no, and it turned it to yes. Cool. Apologies on that one. I'm going to go ahead and give it a first name and last name like we always have. In our previous examples, let's do a last name. And I'm going to do I'm going to do a primary phone number, so just primary phone. I will make it a big int. My choice is to store them as ints instead of strings. Once again, just saving a little bit of disk space, making it more performant. Secondary phone will also be a big int. And I am going to have an email address. That'll be a pretty big string. Some email addresses get pretty large. I'll allow 100 characters. And I'll make sure nothing is null. So we've pretty much gone through this multiple times this morning. Those of you who had it working from the very beginning. Very similar. The only real difference is we do have a primary key here. That's identity. And I do want 2 phone numbers and an email address for this example. I'll click save. It'll prompt me for the table name. We'll use singular this time. Now we have a new table in Delta. We can confirm that, right click, refresh, and there it is. So one of the things that I already mentioned before was I'm going to do a new query window on Delta. and just select. We don't have any customers in there right now, but we don't need them for what I'm describing because I already discussed it before. I am using the table alias again just to show you it's possible. Sometimes I use them, sometimes I don't. Some teams require them, so be ready for that to be required. Now this won't return anything, so I don't have any customers in the database, and that's okay. That's not critical for what I'm about to discuss with you. This is basically what we did right before we went to lunch. I'm just sort of refreshing your memory. And remember I told you that when you have that primary key, which is what customer ID is, we're seeking to it very quickly. However, there are some cases where we want that same sort of performance for seeking, but it's not on customer ID. So a good example, if we look at our table, and I'll expand the columns here, you can look at it any way you feel locally. Depending on your needs, and this is something I want to stress, you really want to address performance problems only as they occur, but we're going to pretend that this table has lots of records, and we do need high performance seeks, that is reads from the table, on a small numbers of records of the full record set, but we don't have the customer IDs. For some reason, that's just what the current need for the current feature is. We have something else. A good example might be email address. Email address is something that has what we call high selectivity. What that means is the values don't repeat very often. They're nearly unique. They're not guaranteed unique. If it was unique, we just call it unique. That's about the highest selectivity you can have, is uniqueness. But emails are pretty close. It's very unlikely that of the people in this class, or even in this city, that any two people have the same email address. So they're near unique. So if we need that sort of lookup, how do we accomplish that? If we go back to our query, obviously we just type the query as normal. So I'm going to change the email address. And this won't actually accomplish anything. I'm just showing you how the code would look. Oops. Still, we don't have any customers. Just pretend we had millions in there. This is us trying to grab, and we'll be even more performant. We'll do first name, last name. How about that? We're just getting that. Maybe we'll get the customer ID too. We don't get any records back because our table is currently empty. But we're really saying filter by the email address and give us back all the customers with first, last name, customer ID for that email address. And there's a good chance in this database there's only one record. But something unfortunate is now happening. If this table had 1 million records in it, it has to read all 1 million. Right, it's got to go to the hard drive. Even if it has cached the data, it's got to go to a cache, which actually has overhead. That actually is a performance problem. The more records you get, the slower this query becomes. Right? You'll sometimes hear people saying that software has a scalability problem. What they mean is, regardless of the fact that it works on a developer's machine or on a test environment that has one active user, it doesn't scale to a large quantity. So when we talk about scalability, that's pretty much what we're talking about. So in this case, if we imagine we had 1 billion customers in this database, it's very likely, even out of 1 billion, that email address only appears once in the record set. It could appear 0 times as well, but it very likely doesn't appear more than once. But would we really want to read all 1 billion customers off the hard drive all at once, just to satisfy one record? Well, of course not. That's going to be a huge performance impact. It will run extremely slow. So wouldn't it be nice if there was a feature that was kind of like a primary key, so that whenever we searched on it, it had a smaller amount of data come back, just the data we wanted. And that feature exists. We call them indexes. So I am going to cover them. I just decided at the last moment. So what is an index? Well, the first thing to remember is that key we created. I don't know if you remember before lunch, but I called it a clustering key. Some people call it a clustered index. All these terms are correct. Well, you see the word index in there. The fact that it says clustered, you can ignore that. But it is an index. And you can think of an index kind of like the index of the back of a book, where you have a book that might have 500 pages. Maybe it's a novel, or it's probably more like a reference material. But it's got 500 pages, and you want to find out every time the word Toyota is mentioned as a brand. Well, what do? Do you read the whole 500 pages and jot down the page numbers yourself? Well, you could. That's totally legitimate. Are you eager to do that job? Does that seem like a great expenditure of your time? No. Wouldn't it be nice if somebody had gone to that book already and taken some of the rare words that were important and put them in the back, and then had the page number so you could get to it quickly. Well, what do we call that? I call that an index. It's exactly what it's called. Same thing. It's the same concept where we take something important that we're gonna look up on, we're gonna use it as a filtering criteria. We put it in the back of that book. We put Toyota, we put pages 3, 119, and 240. Those are 3 pages. Now you only have to read 3 pages instead of 500. Indexes in most databases are some version of that. They're not very magical. They're incredibly powerful, but they're, as far as complexity, they're not really something to be spooked by. They are really just exactly what an index is. And what is an index? It's a duplication so that read performance on certain keywords is faster. It's a deliberate duplication because the word Toyota appeared in the original 3 pages. Now it appears a 4th time. Like, that's duplication. But the exchange you get for that slight duplication at the end of the book is extremely fast reading. And for databases with 1 billion records, you're rarely deleting all of them at once. That's very rare. It's extremely rare to update them all at once. And it's actually extremely rare to read them all at once. Why would you need to read a billion records? You probably need 1 or 2 for any given request made by the web browser. So we can build indexes. And I haven't done this with a designer in so long, but I'm guessing I can right-click New Index and do a non-clustered index. So let's do that. Be sure you expand the customer table. Go to Indexes, New Index, New Clustered Index. I haven't used the designer to do this in so long. I don't even know what this UI is going to look like. Got it. I can figure it out. So it gives us this new pop-up. Now there's a lot going on here, but all that we're really going to do is we're not going to use all the features of the index. Indexes have lots of features. We're going to keep it nice and simple. So you should have this sort of pop-up here. I'm going to make sure I'm streaming successfully. Okay, good. Oh, we got multiple questions. Yes, start up here.
I don't,
New index is to save your customer.
it's not, new index is disabled.
Is
for me.
it grayed out?
Yeah.
mine's grayed out.
Yeah.
Okay.
I don't know why that'd be grayed
I
out.
don't know why it would be either, yeah. Is everybody added a primary key?
Uh-huh,
There's a primary key in there?
uh-huh.
I'm gonna try to save it.
I don't know. Yeah, make sure your table's saved. Make sure your customer.
Make it save. Make sure it's saved. You can right do this refresh.
On the index folder, new index. You can do indexes on Express Station.
Oh, do they have it?
Do I have to go to this place and do this one?
The tools.
Just a quick query of the crew. How many do have new index enabled and can click it? Okay.
EDL time.
No problem. No problem. Did you give them Dev or Express?
Because there's no
Express.
data in the table.
It might only work on Dev.
Maybe.
Because Dev has all the enterprise features. You just can't use it on Pro.
Maybe. I mean,
Okay.
it's there, it's just grayed out.
So what I'm going to do then is, you don't have to follow anymore. I'm still going to do it in front of you because we're not going to make much use of this skill any time later than this moment. I just want to tell you the indexes exist. We're going to quickly create one so you can just watch and enjoy. I'll go through it pretty quick and we'll move on to the next topic because we're not going to base any of the future learning on indexes.
If
Question?
you exit your query, you can actually create a new index.
What's that?
If you exit the query, you can create a new index if you're having an issue creating a new index. So if you have a query open, exit it, and then try to create a new query, refresh it.
Mine still doesn't
It
work.
works for me,
Yeah, it's also working for me now.
so.
2 yeses and 1 no.
Wait,
It works.
I'm going to stick with the plan. Let's not get off topic. I got a lot of things to cover. Just watch the screen. I'm going to create one. We're going to explain once again what it does real quick, and we're going to move on because we're not going to reuse this skill set at any point during these discussions. Non-clustered index is pretty easy. Remember what our query looks like. We want customer ID, last name, first name out of it, and we're going to be querying on email address. Well, this is pretty straightforward. We get this new pop-up, and all we need to do is go to the ad and pick the thing that we're going to search on, which is email address. I've clicked it, I do OK, and I'm just going to do the short version of this since you guys can't follow along. It creates this index. Now it's got a bad name. You would have wanted to give it a great name, but it is, and you won't notice a difference. You'll just have to trust me at this point, that now when I press F5, what it did is it went to this index and searched it for the ABC. And for whatever hits it found in that index, just like looking at the index in the back of a book, it goes to the real table, but it does so on the primary key. So it does effectively if the index was on, if we had this email on 3 customers, it would have 3 independent high performance seeks, 1 record at a time on the database, which is still a lot better than a billion by scanning all a billion. And that's all I was going to show you anyway, so it's okay that you didn't get to do this part. It's not a big deal. I just want to tell you that they exist, why they exist. I want to give you the analogy of the book. And when people talk about performance tuning on databases and index tuning, and they use any term that has the word index in it, clustered index, non-clustered index, covering index, all they're talking about is some form of that analogy of the back of the book. And it's always for read performance. The SQL Server keeps the indexes up to date automatically when you're doing creates, updates, and deletes, so there's no maintenance on your part. But if you think about it, that's the penalty you pay. So if you ask yourself, why don't we just index every column? Well, the reason is because every create, update, and delete would have to update that index. So in general, the really great DBAs try to find a very small amount of indexes that cover a large quantity of queries. That's a pretty advanced topic. It's out of scope. I just want to tell you that that exists. And if you're already sort of getting into databases and you're having fun, that's the cool stuff you get to look forward to as a DBA. I've had the privilege of doing those tunings, and it's a really fun career path. But that's actually all I wanted to talk about with indexes. So it's okay if you feel like you didn't get a chance to experiment with that. Other than the fact that you can't do it yourself, do you have any questions before I move on? Okay. So, I'm going to totally change the topic and just talk for a moment. I opened up this morning by saying this is a relational database. So SQL Server, Postgres, MySQL, Oracle, these are all relational databases. It's all about relating data together. And so far, we don't really have any relationships in the data we've built so far today. It's all been in a single table. Now, you could make an argument that there's a relationship between the primary key and the other columns. But if you really think about it, this was pretty straightforward, right? We had what was effectively a single sheet workbook in Excel. And we had a single table here with columns and rows. Not very exciting. The real power here comes from relating the data to each other. So if we look at the schema, the actual columns on this table, I want you to imagine you're at a job right now, and this is the table that you have. You have a customer's table, and this is what it looks like. It's got a primary phone and a secondary phone. What if your boss came up to you and said, we now want to support 3 phone numbers? What are you going to do?
Right-click design.
Right-click design. You're going to add a 3rd column. You could do that. You could then change all the application code to read that, and of course display that on the UI. What if he came up to you a week later and said he wanted a 4th one? What are you going to do? Right-click design. What about a 5th one?
Right-click.
What about a 6th one?
Why don't you just create a new table?
Why don't you just create a new table? Great answer, or great question. That's a question, but it's really the answer I'm seeking. What she said was, why don't you create a new table, for those in Winston-Salem. That's correct. If you think about it, I wanted to sort of show this pattern. There's nothing wrong with this database design per se. I think you can't sort of objectively look at it and say this table's badly designed. But it does suffer from something, and that is it's got 2 columns for phone, and the moment that a customer asks you for like a 2nd feature, it's very safe to assume they're going to ask for a 3rd of that same type, or a 4th or a 5th. It's a good predictor for change in the future. And what if I were to inform you that the act of adding a column was actually tough in a given product? There's ways that it can become tough. I won't go into those, but sometimes, yes, you can right-click on Designer and add the column, but maybe the application starts crashing because it expected there to be precisely 6 columns in there, and now there's 7. And you might not know that till you deploy. So you have a situation where the reality of it is what the customers really probably wants, what your boss probably meant at the beginning, was we would like them to have a set of phone numbers. And what's a set? A set's a table. So that's what we are going to do now. Make sure I'm looking at my notes here, I don't leave anything out. I think the only thing I'll mention that's in my notes before we start the follow-along part, I'm not sure what was done in JavaScript, but when we talk about C#, one of the things you're going to notice in object-oriented languages like C#, which I'll be talking about in a week, is generally objects own their children. For lack of a better word, you can say that their parents own their children. So you might have a customer object and it'll have a set of phone numbers. You might not have seen that yet, no problem. You'll see that in a week. What I want you to realize is that in relational databases, the relationship is the opposite direction. Children point to their parents. So right now, we have a table of customer that has 2 phone numbers in it, but we're going to remove those phone numbers and put them in another table, as was suggested, and that table is going to point to customers. So children point to parents. Just memorize that sentence, and I'm going to show you that. DDL. All right, I want you to follow along, but we're going to do things a little bit different this time. So let's go ahead and create another database. I'm going to call mine Echo. It's the next letter in the alphabet. Now you might have at this point gotten tired of creating customer tables. I'm tired of creating them in front of you, so we're going to do a little bit different this time. If you haven't already heard, I think Ali did mention it. I think he might have mentioned it, but I'll just restate it in case my memory's failing. Remember that everything in SQL Server is actually a script of some sort. It's just a set of strings, some sort of command is sent. Well, the commands generally fall into one of 2 categories. One is called DML, that's data manipulation language. That's what you have seen all day so far with me. All the select statements, the inserts, the updates and the deletes are all data manipulation types of queries. That's your category 1, so what you've seen so far. We're now going to move into category 2, the other one. We call those DDL, data definition language. This is how we define the schema of the database. The schema is the tables, the indexes, and a whole lot of other things we haven't talked about yet. But they can all be done also with scripts. There's basically nothing that SSMS can do with this UI that you can't do with a script. It's actually all scriptable. So we already created a customer table in the Delta database, and now we have a new one called Echo, and I actually want to create a new customer table in the new database, Echo, but I want it to have a slightly different schema. So instead of having to do it the hard way, open the designer, type in customer ID, set it to int, key, blah, 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 and do all this again in front of you, we are going to have we're going to cheat a little bit. So if you go to Delta and you right click, and be sure to follow here, we select the customer table. I want to make sure that this is not too confusing. Right click, and you got a lot of options. Right here near the top is script table as, create to, new query window. And what we're saying is, SSMS, please inspect the definition of that table and turn that into a script that could be executed and plop that in a new window. So this is how we create tables without the designer, because we've seen the designer multiple times. There's a little bit of noise on the screen, so for the sake of presentation, I'm going to just sort of get rid of all but some of this important stuff. And if you look, this is actually a script typed for us, which is how to create the customer table from scratch. Okay, you'll actually see that clustering key is defined. It's got a name here. It points to that customer. That identity 1-1, that's where it's incrementing it, starting at the number 1, incrementing it by 1. And of course, you can see all of our data columns, their data types, and whether or not they are null. There's some other noise down here. We will ignore all of that. We will not talk about that. Question?
Can you add comments in the editor? Like you can do in like...
Yeah, you can put it here. They're all scripts, so you can put, the question was, can we put comments here? Yes, you can put comments in any of these scripts. And it just begins with dash dash. Yeah, and that will vary from language to language. You're going to have front slash in some languages. You'll have dash dash in other languages.
Multi-line looks like JavaScript, right?
I think it's something like that.
Yeah.
Yeah, that's the multi-line comment. I don't see those too often, but they do exist. Yes, question?
For the customer ID, the identity, does the 1-1 stand for like 1 out of like the total amount of like entries in the data point in the database, or?
Gotcha. So the question is, what does this identity really mean? All these are the number 1, and you're seeing it twice.
Yeah.
One of these is start at the number 1
okay.
for new records. The other is how much to increment per record.
Okay.
So in the vast majority of databases, it's always 1-1.
Okay.
I've never seen a company start at a number other than 1. It's possible, never seen it. And I've never seen anybody increment by more than 1. Why would you skip numbers? You're just eating up space, right? Remember, you can't reuse them. They get they skip over deleted records. So I've never seen it not 1, 1. It's possible, obviously it's possible, but I could not imagine going that direction. I've never done that. So we've scripted this out, but I haven't run it yet. And the reason, if you look at the top left, I'm still pointed at Delta. In fact, if I press F5 right now, it will not work, because there's already a table named customer in the Delta database. But all I'm going to do is cheat. Drop this down and go to Echo. You'll notice the red squigglies went away. So now I can actually, if I pressed, I'm not pressing it yet, I could press F5 and it would create the customer table in the Echo database immediately, just like that. It would have an identical schema. But I want to be clear. If the old table had data in it, the data does not come with it. This is DDL only, schema only. It's a way to copy the structure of the database, but not the data. All right, now all morning we've been talking about we've manually built the schema and we've used queries to do only data manipulation, DML. But this is not data. This is just schema. You can do tables, you can do these things called views, which we'll talk about later, indexes, can all be scripted this way.
And that little drop down is just where that query is pointing, right? Like
Yep.
which database the thing is pointing to.
Yes, and you can also see it in the very bottom right, there's a little word echo. Do be careful with this. There are many mistakes that have been made by many a DBA where they had some rather aggressive script that did something possibly destructive or major and accidentally had the production server selected right up here. Be very conservative when you're not working locally. You're working locally today. Do whatever you want. You can break databases, create them, no problem. You're working locally on your own laptops, there's no harm. But once you get on the job, you gotta be more conservative about where these things are targeted. We can be cavalier because we can't earn anything but our own databases right here.
Why is it that my red squiggly would still be there if I went to Echo, which is empty?
I don't know.
We won't worry about it.
We haven't pressed F5 yet. If F5 doesn't work, I'll have Harper help you.
Cool.
So we are targeting Echo, but I haven't pressed F5 yet, and here's why. We started talking about phone number duplication, right? Putting in a 3rd column, putting in a 4th column. What we really want is a customer table that has no phone numbers on it. Doesn't even know phone numbers exist, because we're going to add another table that has phone numbers in just a moment. So what I'm going to do is I'm going to go up here. So I've cheated. I've let SSMS write the script for me, and I'm just going to manually strip out the 2 numbers. You don't have to do the sound effect if you don't want to, but that's what I did.
It won't work otherwise.
It won't work without the sound effect. Right. Now I'm going to press F5. So what this will do, it'll create a customer table that's almost like the one in Delta, but without those 2 columns. Command's completed successfully. And we can confirm that by going down to Echo and expanding tables. We will see a customer table, and if we look at its columns, we will see that it looks very similar to Delta. I can almost get them both on the screen, but not, almost. But it is missing the 2 phone numbers. Right, so we're part of the way there. We have the customer table. We're not going to put any rows in it just yet. But now we can create the new phone numbers table. Well, we have sort of a template here for a table that doesn't exist yet. So let's cheat and reuse that. So do follow along here. Our goal here now is to create the table that holds phone numbers. Right, so we're going to be storing phone numbers separate from customers. They won't be physically in the same table, but we are going to relate them via a relationship in just a moment. I'm just going to call this phone number. Okay, so there's our table. I'm also going to change its primary key to phone number ID. It will also be int identity11, not null, just like the other table. It's going to have its own independent set of IDs. It won't be the same set. It'll start over at the number 1. So customer number 1 and phone number 1 are not the same row. There'll be 2 different ones in 2 different tables. We'll actually call this, I'll just call it phone number. Sort of duplicating name. That's probably a bad name. I'll just put the word value on there. Not a great name choice, but I'm not going to be focused on that. So So you'll notice I called it phone number. I changed it to big int because we're going to store it as an integer, try to be efficient. We did have a parentheses there for the size of the string. That doesn't apply to big int, so I just stripped that right off. And I left this not null. We don't need these last two, so I'm going to nuke that. We're doing this once again the manual way. So we've been using Designer all morning, which is the easier way with your fingertips, especially when you're learning. But I wanted to show you the DDL way. It's a little bit more tedious, right? We keep on having to replace the word customer with phone number, and I'm still not finished. We got to keep going. But I wanted you to see and really appreciate that you can start from nothingness and use just a script, create tables as much as you want. So I'll change the word customer here, and I think there's nothing more here I care about. There is not. And I have not pressed F5 yet, and that's on purpose. If we look at this, this is pretty good. This is a table that if we did press F5 and actually created this, would have a set of phone numbers in it. But how would you know which customer it applied to? We have a question in the back?
So if you abstract everything that you can from a table, like the phone number, the address, all to be in a separate table, is it going to take longer for you to go and get that information and bring it back?
Possibly. And you're actually asking a question. So the question is, if I extract all of these columns in different tables, would it take longer to look up? And my answer is yes, possibly. So we're actually talking about a topic. Your question is actually about the topic of good database design. And there is no one correct database design. The reason that people can remain employed is that there isn't one perfect design. Different products will have different needs. They'll have different read and write needs, which are generally low performance events because of the keeping indexes up to date and that sort of thing. And there are read performance needs. You know, is it going to be live data? Will it be late? There's a very large amount of expertise that one can gain to make great decisions for a given company's need, for a given customer's need, what that design would be. In some cases, it's a good idea to break out pretty much everything. There are other cases where that's overkill and makes things worse. It will vary from need to need, and I don't want to give you a single correct answer. I've made this one up just because it's a good, example one, but that will vary. And once again, that's part of the fun of the work. Is you don't walk into every company with a recipe, you walk in with a set of questions. Ali sort of touched on this earlier. You're going to walk in, you're going to determine what are the actual needs, how often do they use this feature versus that feature, which one gets hit the most, under what conditions, at what time of day, and by whom. And there's a lot of context, and only after the evaluation of all that context can you actually make a great decision on that. So yes, maybe, depends. Good question though. So once again, if I pressed F5 here, I would have just a list of phone numbers, but they would be orphaned. There's no customer, right, relationship here. I think I will use the designer to do that part because that's kind of tough to type those from scratch. So I will press F5, and it will run. So go ahead and do that. If we refresh our tables list, we do have a phone number table. Great, it's got its primary key, it's got its two values, but once again, it's orphaned, right? If I started putting numbers there, which customer would it point to? And so that, to open them both up here, just to re-emphasize, we're going to modify the child table, the child data, the thing that is a subordinate to the customer, which is the phone numbers. That's going to have the pointer that direction. We're not going to have customer point at phone number. That's not how that works. That's what you do in OO languages, but not in a relational database. So let's open this in Designer because that's just easier. And I'm sort of just showing you that there's multiple ways to do this. You can use designers if you want. Some people use designers all the time, even as advanced DBAs, and some prefer scripts. It's up to you, whatever feels best.
Did you insert column?
Yeah, I did it. I'm sorry, I moved really quick there, didn't I? I'll start over. So I did go to the design, right? So here's the naked table. And I just I selected the second column, and I right-clicked and did an insert. Now the order is not critical. It would have been fine to put this as a third column, but in general, they generally look better on the screen when other people on your team are trying to understand your design. If these other columns, which I'll give them a proper name shortly, are close to the primary key. It just looks a little better. That way they're not buried in what I would call fluff columns, columns that have data that as a developer you don't really care about. It's just sort of strings typed by customers. So what's it going to be? Well, it's going to be a pointer to customer. So it's going to have a customer ID column. It needs to be the same type. And I'll go not null on that one. And well, my resolution is a little weird. I need to find where are the relationships. There they are. So there is a button, depending on your resolution, it should be somewhere near the top right. You can do this relationships click. What we're going to do is we're going to build a new relationship, because we have the phone numbers table already created, we have customers, but we haven't related them yet. All right. So I'm going to click add. It automatically gives it a name. Usually you're going to fix that, but for brevity I will not fix it yet. I'm going to expand this. Was there a question? I thought I saw a hand go up. Okay. I expanded table and column specification. There's the little triple dots here. Now we get to decide which table is in charge and which one is the child. And in this case, we already know. The foreign key table is the one that we're in. So this is actually what we're building right now. It's called a foreign key. All right, we've already talked about a primary key. Primary key is the key for that record. A foreign key is where we're pointing to a different primary key somewhere else. We're pointing to a parent in a relational database. The parent is in charge, and the child points to that parent. I'm going to keep re-emphasizing that because when I learned this stuff, nobody said it clearly, so I was always confused which direction the arrows went. The arrows went. So they go up. So the foreign key table is the table we're in, which is phone number. We pick customer ID. The primary key table is the parent, the thing that owns phone numbers. What owns a phone number? A customer. Customers have phone numbers, therefore they own them. So I'm going to do customer. It's going to pause, and I get to select customer ID. Oops. So I did this in a backwards order. Both of these need to say customer ID. Make sure they both say that, because I just saw my UI flip that one. Functionality I'm not used to. So that's how it should look before you click OK. So I'm going to leave it on the screen a moment and just re-emphasize the primary key, the owner of the data, is customer. The child of that data is phone number, and that's when it's a foreign key. Yeah.
Winston's asking if you could just, leave it up there for a second, but if you can kind of go over that again. I think that in the upper right-hand corner where the foreign key thing was, it's probably under the picture. Yeah.
Oh, it is under the picture.
You were kind of concerned as to where that was.
Yeah, my picture for them is in the top right. So I'm going to cancel out of this. Everybody else who's following and is with me, don't cancel it. You can just stay there. I'm going to do a little trickery here. Oh, that's even worse, isn't it? Jeez. Well, now they can at least see under the picture. So to reiterate, I went to design on phone number. I inserted the new column. I named it customer ID because that's who the parent's going to be. Its type was integer. I did make it not nullable. All right. And then while I had that, while I still had this open before I clicked save, because I don't need to save it yet. I could, but there's no real reason to. The top right, which is the part that was covered, I clicked on relationships. So on my screen, in my version of SSMS, that's a green plus sign at the top left of the icon, really small, but I'm moving my mouse around it, get some attention to it. And that gets us to a list of relationships for this table. Now initially when you open it up, it will be blank over here, and I clicked add. But since I've already added it, it's actually already saved it in there. So I'm going to get back to where I was. I expanded tables and column specification. Actually don't have to expand it, I can just click the dots. And that gets us to that main definition, which I now need to fix again. This is what it should look like. Customer, customer, phone number, customer. This is what the relationship should look like. You can rename it. Most products you'll rename it. I'm going to leave the name alone right now. I don't really care about it for the presentation. Hopefully everybody will be caught up. We'll have the tables and columns open. Once again, customer is the parent, phone number is the child points to parent. It's pointing to customer ID on the other table. So the customer ID and phone numbers is pointing to the customer ID in customer. If I click OK, close this, and save the table. So just close all the way out, save the table. It will give you a warning. If you haven't turned the warning off, just say yes, it will work. It works because we don't have data in there. That's why I didn't actually add any rows to this. I wanted all this UI stuff to work. If we refresh the columns on phone number, you're going to see a couple things. First off, our new customer ID column is there. But if you look at the icon next to it, it also has a special icon. That icon is just telling you it's a foreign key to something. And if you have a good naming convention in your product, it'll be named the column that it points to, or something that you could easily infer the correct column that it points to. So what we have, effectively, I wonder if I can, we've created a relationship. That's why that button says relationship. And this relationship has a proper name. In pretty much any relational database discussion, there are basically three kinds of relationships. There's a one-to-one relationship. And this is where you have a child table where the primary keys are effectively the same thing. You could argue that on the customer table, customer ID is one-to-one with first name. What does that mean? Well, for a given single first name, it has a one-to-one relationship with its primary key. One-to-ones are uncommon, so if it sounds confusing, don't worry about it. The second one is the really key one that you got to know, and that's the one-to-many. And that's what we just now created. A one-to-many relationship means we have, in our example, one customer can have many phone numbers. That's what one-to-many means. It's that simple. One customer can have many phone numbers. You can even say that sentence roughly backwards. You could say phone numbers are many to one with customer, because you can have many phone numbers for a single customer. A single phone number cannot belong to two customers. That's not possible here. You could have a duplicate row with the same value in it. We haven't constrained that. But for a given single row, if you look at the phone numbers table as we've designed it, a single phone number points to exactly one customer. Not 0, not 2. It's got to be 1. So that's a one-to-many relationship. And I've said the words a lot, but you're going to need to really let that one sink in. If it doesn't click for you immediately, that's okay, but you don't want to skip over this point. Relational databases are all about their relationships. That's why they're called relational databases. Even if it might not be comfortable immediately, but this is the part you'll want to study if it doesn't feel comfortable. What is a one-to-one? What's a one-to-many? And the third category is what we call many-to-manys. And that's effectively two one-to-manys, which I'll talk about later. It's a third type, and that's where you can arrange a database table, set of tables, at least 3 of them, to arrange a many-to-many relationship. But let's focus on the one-to-many. Okay? And I'm going to start inserting data in a moment to really clarify this. Your question?
Would you mind going over how to insert the primary key? How to get that? Or is that too far? If it's too far, it's fine.
I think I'd prefer Harper help you on that one.
Okay.
Once again, remember that I cheated here. I was able to script out the customer table, so it got created for me correctly when I did the other 2 tables. Thank you, Harper. So we've got these tables in here. I'm going to expand the screen again, so it's a little bit bigger. We have the 2 tables, right? We got customer and phone numbers, but there's no data in it. So if you're lost, it's probably because you haven't seen any data. So I'm going to type some data in it just to talk about what we're going to see. And feel free to follow along. So we're in Echo. We're going to do a new query. Got a new query window open. The first thing we do need is some customers. So we'll do 2 of them. We'll do Bob Smith and Alice Smith, just like we've been doing. You can use any names you wish, as long as you can tell them apart. Remember, I have red squigglies because I didn't do that IntelliSense stuff. You can ignore it, and you can see that it works even when I don't use it. So I've inserted a Bob. I'll go ahead and do Alice as well. I'll make them keep the same email address because it doesn't matter right now. And I will move this to a new window, but we are going to want to check out those customers. You can do this in the same window. I'm about to open a new window after everybody catches up on the insert. You'll notice this insert has no phone numbers because the customer table has no phone numbers. We removed those fields. Those columns are gone now. So in a new window, we'll check out what sort of customers we got. Bob and Alice, They've got their own customer IDs. Those were generated for us, IDs 1 and 2. We're going to be focusing on those numbers 1 and 2, so do pay attention to those. So we got our 2 customers in there. I'm also going to have a phone number. You'll notice there are no phone numbers in the database. That table's empty. Well, we're going to change that. So let's say I want to add 2 phone numbers to Bob. I don't need my customer inserts. I'm going to start this off from scratch. Customer ID, and I just called it value. So we're about to insert a new phone number. Let's say we know the phone number. I'll go ahead and just put a comma in here, and it's just 555-1234. No area code on that one. So you know that that's the phone number value. What do we put for customer ID? If it's going to be for Bob, what will that ID be? 1. That's exactly right. What we're doing here when we insert this is we're saying, here's the phone number, 555-1234, and please make it a child of Bob, because his number is number 1 in that other table. I press F5, and it works. And if we immediately go to my select, I'm going to go back and forth between these 2 windows. One of them I'm going to modify data, one I'm going to just update the data. Here we go. This is the first time that you have created, or if you're just watching, have seen probably, a child record put in a foreign key relationship. So our phone number got created. Now remember, it has its own primary key. It's got its own identifier set that has its own identity specification. So it starts off, and I'm going to highlight it blue, with the number 1. But we manually told it in our insert that the customer ID for Bob was number 1. That's a different primary key. It's 2 different number 1s. These are 2 different numbers, unique identifiers for their respective tables. And of course our value, 555-1234. Okay? I'm going to go back to that script, and I'm going to give him a second number. I leave the customer ID as the number 1. But I'm going to change the phone number 444-1234. How about that? Press F5, that will run. We go back to the data, and what do we see? We now see 2 different phone numbers. Their primary keys are 1 and 2. Both are related to Bob. They're both child records of Bob. Both of them point at Bob. We don't want to leave Alice out, so we're going to give her 1. Her customer ID is 2. So she gets a new phone number. We'll give her a weird one. We run that, so there's now a 3rd phone number in the database. When we review the data, we see that there is now a 3rd phone number with its own primary key of 3, but it points to the 2nd customer, who is Alice. So Bob now has 2 phone numbers, Alice has 1. Now you'll notice we didn't have to change the schema. Before we were stuck. When we had a primary, secondary phone number, we couldn't add a 3rd one without changing the whole schema. But obviously, if Bob needs a 3rd number, it's not a schema change. It is simply a new record. So we've done here what we generally call something like a pivot, where it used to be column storage stored our phone numbers in a horizontal fashion across the database. Now it's in a vertical storage, which is rows. So instead of going horizontally out to the horizon, we go down underground. And you can see it comes up, the customer ID is number 1 for phone number number 4. So those are all connected to, those 3 are connected to Bob. So Bob has 3 numbers, Alice has 1. Now as humans, that can be kind of weird, right? Because you could end up with all kinds of numbers. This is a pretty small record set. If you had millions of records, these numbers would be huge. They would, 73492 with customer 43793 and the phone number of X, whatever that would be. They're not easily human readable. However, they are extremely performant. This is a relational database where the majority of its feature set is about relationships like this. And you're probably underestimating right now how powerful this is. But the fact that we don't have to put Bob's name in this phone number table keeps this phone number table very tiny. as far as data size per record. So we could put millions in here really efficiently, and we could look up on them really efficiently. And that's going to be the real power. So we've designed the relationship, we've put in some data, and we're about to move on to a little bit more of an advanced query technique. Are there any questions
Can
from
we go
anyone?
back for just 1 second and
Yes.
show me how to put in multiple IDs for the same person?
Yes, I
There we
just
go.
ran this
Insert
query
into.
multiple times where
With
this
different
first
phone
number,
numbers.
yeah, were different phone numbers, but the first number didn't change.
Right, okay.
Yeah, and in fact, you're probably asking, what if I put an invalid number in there? And this is a wonderful feature of relational databases. So remember, this first number is customer ID. We only have two customers, customer number 1 and number 2. I'll put a ridiculously wrong number in there and press F5, and it won't work. So one of the great things about how these pieces of software work, like SQL Server, is when you do design your database as well, and you put those real foreign keys in there, that you actually attach them with that relationship feature, the database won't let you put in invalid data. Now that's a bit of a stretch of a statement. It won't let you build the wrong relationship or an impossible relationship. You can't point at a user, a customer named 9999, because they don't exist, and that's why this is red. And that's going to be great. A lot of developers get frustrated when they see this kind of red error message, the insert statement conflicted, blah, 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 but it's actually saving them from a mistake. They've obviously typed the code wrong. Question?
For example, if I wanted to put, say, multiple people into my table at the same time, in like one thingy, would I copy and paste all of that, or can I just repeat the values part? So do I have to repeat the insert?
Can you repeat values? Do you know? So
Does that make sense?
Yeah, the question is, can she insert multiple rows with multiple values clauses?
Before I hit F5, or do I have to do it one at a time?
You would just
I don't
have
know.
multiple statements. You can do a select from a temp table
Mm-hmm.
into another table, so you could kind of build up your query that way. If you had a CSV or something like that.
I don't think this works. Ali might know, but I don't think that there's,
No.
if there's a syntax here that works. Yeah, it's complaining all the time. It's probably separate statements. There are ways to do bulk inserts, but
Okay.
as far as here, I think you're asking, can you like, it's obviously not working. I don't think, that's either not possible or I don't know it.
You would just have that whole statement over and over again.
Okay, so the insert and the values over and over. Okay.
Yep.
Yeah, if you actually knew you needed to. This does happen as two different independent inserts,
Right.
but if your quantity is pretty low, this is fine. This would work. I don't want to press F5 because I want the data set to remain simple for my next example. But it would add 2 more records under Bob if I press F5 right now. But I don't want him to have too many because my example is going to get too complicated for the next follow through. There may be a syntax that allows it, but I'm not aware of one. Ali might know.
Oh, yeah. Insert into table, column, and then values with the things like that
Yeah.
separated by commas.
Got it.
So like you could do like
Yep.
little value bunches.
Like that?
Yes.
Oh.
Yeah, so the red squiggly went away. I thought there was a way. Was that Ali helping us out?
Yeah.
I hope so.
Yeah.
I'm still not going to press F5, but the answer now is yes. So good job, Ali.
I didn't know that.
Yeah, I didn't either. It felt like it could be possible, but I had never done it. Learn something new every day. And that's something we all do. Don't worry. If I said I've been doing this 20 years, I still learn every day. So thank you, Ali. But I don't want to press F5, so I want to keep this simple. Did we have another question about relationships? Did you
Actually, just wanted to see how you, before you even created the foreign key, when you had the table, the script set up for Delta, how you transferred that table to Echo.
Great, I'll mimic it, but I won't actually run it again. I went to the Delta, so the question is, how did I get the Delta customer into Echo?
Yeah.
I went to Delta, right-clicked and did script table, ask create to new query window.
Yeah.
That's just me asking SSMS to generate a script for me. It just writes code for me.
Okay.
It's not a feature of database, really, it's really a feature of SSMS. I opened this, and I did something very subtle. I went up here to the top left, where it says Delta, and I made it Echo.
Okay.
And I had actually deleted all this. I could have also just changed this use to Echo.
Okay.
Both would get the job done. I'm getting red squigglies now because it would be a duplicate table. It won't actually run, but that's what I did.
Okay.
And remember, I did remove both phone numbers because the whole point of this exercise is not to have them in that table any longer.
Okay.
We also have another benefit that's occurred with the fact that I've separated out the phone numbers from the customer, and this goes back to the gentleman who was in the back there. I've actually also, I shrank the customer table a little bit. So now select star queries that need lots of records from customer are actually more efficient, kind of by accident, right? Because I pulled those out. Before, the phone numbers were in there and they were kind of widening up the data. But if I pulled those phone numbers out and I rarely need them, like if the design of my current product, and this will vary from product to product, but if the design is phone numbers are rarely needed, but customer first name and last names are needed often, this was a great move because I moved that phone number data out of the way. So now large queries that scan 100,000 records in customer are now smaller. They take up a lot less space. We were using big ints, I believe, so we were saving 16 bytes per row. Doesn't sound like much until you have 1,000 of them. Well, that's 16 kilobytes. A million of them, that's 16 megabytes. A billion, 16 gigabytes. It's a lot of data to be running faster. So as these databases become more, the official term is normalized, these advanced normalization techniques that we're using where you really bring the relationships out, they generally improve. But you can, to my answer to the gentleman's question earlier, you can go too far. But that will vary from product to product. Any other questions about how we set up the foreign key relationship and how we inserted these records? Or Bob having 3 emails? Or phone numbers, excuse me? None? All right. Get to do some more advanced query stuff. So when you look at this, let me look at my notes just real quick.
I have one question, sorry.
Go ahead.
Can you import data from something else, like say a notepad
Yes.
file? Okay.
Yeah, the question is, can you import data? I won't be covering that, but since you asked, I would show what you could do. You can go to any database. There's tasks and import data.
Okay.
And this uses a whole different feature set that I won't be going over at any point, but I will show that it works, just to show what kind of data sources are available, because you were, there's quite a few. The most common one is Excel. Very often customers will send in CSV, that's comma separated values files. They work if you use the flat file source, Excel files. These other competitors like Oracle, there are ways to get huge amounts of data into SQL efficiently, because I know what you were thinking. You don't want to type insert a billion times from some other data source. Data migration is a whole career in and of itself.
Okay.
Question?
Winston was asking why create 2 tables again? Why are there 2 instead of 1?
So the question was, why create 2 tables in our example here for Echo? Well, our reasoning was, I asked earlier when we, and I'll pull Delta up because it had the old version of the table, which I'll highlight here. It had a primary phone and a secondary phone, and the scenario I presented was, what if your boss comes to you and asks for a third phone number? The third phone number, yes, you could go into Designer, you could go in here, you could right-click Design, you could go in and insert a new column, but what if he asked for a 4th one? What if he asked for a 5th one? And although you haven't probably experienced it yet on the job, sometimes the addition of a new column or changing of a schema has a detrimental effect on the software. In perfectly written software, there are no effects, but since there really is no perfect software, it's written by humans, it's got a few shortcomings in it inevitably. Sometimes there are situations where the quantity of records coming back from select star, the software can't handle a change in that. So if you jam in a new 3rd phone number here, you break some other feature far away. And those bugs can be really, really dramatic. They're hard to track down because it's hard to understand what the cause and effect is. So that's one reason. One reason can be that your boss keeps coming to you and asks for the same thing, and you want it to turn it from a column-based solution, which is what Delta is, to a row-based solution, where I could literally give Bob 300,000 phone numbers if I really wanted to. If that guy has a crazy amount of phones, I could give it to him. I'm not sure if there's a column limit on SQL Server, but my guess is there is. It's probably in the thousands, maybe tens of thousands, but I highly doubt I could put 1 billion columns on, but I can put 1 billion rows. So one reason is just
Inefficient after a while.
Yeah, I'm sure. Oh yeah, it gets incredibly inefficient for all other queries too, not just the ones you're trying to run. There's a little bit more of an academic answer that I'm not going to be covering, and that topic is normalization. Feel free to Google that. I decided in my presentation I didn't really have time to cover that. I'm only going to be talking to you guys about this for 3 days total. But there are other reasons besides that one scenario, but I find that scenario is the most relatable when you're new. which is I don't want to have to keep changing the structure of the database just because a new kind of phone number comes in. Because if you think about it, I could go to this phone number table and start categorizing them, right? Primary, secondary, mobile, home. I could put on flags like is textable, right? Because home phones are not textable, landlines aren't, but cell phones are. I could really beef up the phone number nature. Well, if I had the phone number stored in the customer table, I would have to have all of the associated columns about phone numbers in the customers table. So I would have the is textable flag for primary and is textable for secondary. So when your boss asks you for a third phone number, you might have to add a set of columns with that old technique. It's just going to get out of hand. You're going to become frustrated because you're going to be packing phone number data into a customer table, when phone numbers might be in your product what I generally call first-class citizens, something that is so important and actually has a lot of properties related to it. In my contrived example, I just have a value field, but everyone in here knows that there's a difference between mobile and landlines. One can receive text, one can't, right? One could be a work number. There could be extensions on some and maybe not on others. And so this table could, in a real product, it's probably going to have a lot more columns than this. You wouldn't want all of those columns packed in customer multiple times over. And as I mentioned earlier, there are implicit performance benefits. If I have a product where phone numbers are often accessed independently of customers and customers are often accessed independently of phone numbers, activities, CRUD activities, create, read, update, and delete, on customer become more efficient once the phone number data has been pushed away from it. Because now they're not really tightly wound. They have a relationship, which is enforced, but when you scan over the customer table, select star from customer, you don't touch the phone numbers table at all. And the same is true in the inverse. Select star from phone numbers doesn't touch customers. And one of the things you'll find on enterprise products is there are features in SQL that keep all the data intact. We call that locking. So certain records get locked as queries are running over top of them, and you can have contention on those rows. But if you've followed procedures like we've done here, intensive queries against customer won't slow down phone number queries. So you get to draw these boundaries between things as far as locking and contention. So there's all kinds of reasons. I gave one, I've just now given another, but the list is actually pretty long. And there's even academic ones that I won't be covering. What was I going to talk about next? I lost my train of thought. One-to-many, yeah, phone numbers. Got it. All right, let me close this because that was Delta. Let me make sure echoes on the screen. Okay, so here's the data. I'll press F5 to make sure we're up to date. Bob has 3 emails. Alice has 1. Well, obviously, if all I needed was one or the other of these data sets, I can do that. I can get all the customers. There they are. I could also get only the phone numbers. But if you look at this table, if all I need is the phone numbers, great. But it's usually unlikely that I need a phone number without knowing more about the customer. So if my application developer says, hey, I want a list of all the phone numbers for customer X. Well, I can't get it with this query, can I? Actually, let me revise that because I could get that from the query. Let's say the application developer wants the customer's name and their phone number. That I can't get from either one of these independent queries. I get names on this one, but not phone numbers. On this one, I get phone numbers, but no names. So I can't get both. At least not with this. And so we're going to talk about a new, fundamental, critical thing that you're going to need to know when working with these databases, and those are called joins. So if you think back to what Ali was talking about at the beginning, as first thing he said earlier this morning, he talked about Venn diagrams. I want you to re-remember everything you've learned in life about Venn diagrams. You said you're a math teacher, you do Venn diagrams. We probably have done that science. A lot of science classes talk about Venn diagrams and overlaps. I want you to bring that back into your brain. If you don't know what those are, feel free to Google it real quick. I want you to imagine all those circles because we're going to talk about joins, and joins are effectively the database version implementation of Venn diagrams. So everything he said earlier was true, and now we're going to talk about it. So let's say the application developer wanted every phone number in the database with the person's first name and the customer ID. They didn't even want phone number IDs. They just want list of customers, list of phone numbers, customer first name, customer ID. They want those 3 columns back. Here's what we can do. So we already know that that's not good enough. We can do what's called a join. There are many different kinds of join. The ones that you'll do most often are called inner joins. You can actually type the word inner join here, but the shorthand is just join. So what does join mean? Join is a way to reassemble a relationship. You can put together any relationship between any data. You will almost always do it on a real relationship. In this case, we have a one-to-many from customer to phone number. We're going to join in the same way that relationship is built, which is on customer ID. So we type join. The next thing we type is the other table. Well, we all know what that's going to be. That's going to be customer. I'm going to give it an alias. And here's where the aliases for tables really starts to pay off. It makes typing the rest of this join a lot easier, especially when you have multiple joins, which we'll talk about later. So it's on, and you pick the column that you're joining on. It's the same columns as your relationship was. So just pick the same one. In almost every case in your life, that'll be the correct choice. There are advanced scenarios, but they're rare. So if you press P, the IntelliSense goes ahead and gives you customer ID equals C.customer ID. Alright, so what we're telling SQL is go ahead and select everything you can from phone number, but as you're selecting it, take a look at the customer table. Whenever you have a customer ID on phone numbers, go to that customer table and grab that customer out and attach them together. Okay? In a Venn diagram, this would be the intersection point in the middle. Not the left, not the right, but the center.
Are we typing phone number first because that's the child? Or does it matter?
It's not critical. It's not critical. So the question is, are we typing phone numbers first because it's the child? My answer to that is actually yes, that's why I typed it that way. You can write this backwards to how I wrote it, and it will still work correctly. So the computer doesn't care. I think it's more easier to read by starting with the children. That's a personal preference. Just a personal preference. I've even been on teams where we argue over whether this goes on the left or this goes on the left. Those arguments to the computer are not relevant. They're only relevant to people. It's a stylistic difference. Whenever I say stylistic difference, I mean just a subjective human thing. The computer doesn't care what you type. It works the same way. So if you do a drum roll, I'm leaving it select star right now, and run just that section. What do we see? We see the Venn diagram with the intersection right at the middle. What it did is it grabbed all 4 phone numbers. Remember, there are 4 of them. And every time it found a phone number, it took the customer ID. That's what this predicate right here, this join predicate, is talking about. It looked up on the customer table and attached the records next to each other. So it's as if there is now a table. It looks like there's a table in the database that's a smash together of the two. It's a virtual sort of look at that table. Now this isn't what the developer looked for just yet, but you can see it's starting to come together. We have the correct data on the screen. We have too much, but we have the correct data. And all it did was line up on the customer IDs. Right? Customer number 1 was lined up, customer number 1 was lined up, customer number 2, customer number 1. Whatever it found in the original phone number table is what it joined on. Now the application developer told us what he wanted. C.customer ID, C.first name, P.phone number value. Remember, he wanted all phone numbers in the database, the first name of the customers they applied to, and he wants their primary key, the customer's primary key. So all I did was turn that star into something much more performant. If we run this one, that is precisely what the person wanted, what the developer wanted. All the phone numbers and their corresponding customer first names and the customer ID. He probably wants the customer ID because after this query runs, he's going to do something with that ID. He might put it in a web browser and store it in a URL. He might do a subsequent query. We don't know. We don't care. These are what he wanted, and we have given him exactly what he wanted. So if you look at this, I want to stress something that's happening that you might not appreciate just yet, because we're working with such small data sets in a classroom environment. You guys have been learning some JavaScript. I assume that people learned loops, Harper? We've been talking about loops?
What's that?
Loops in JavaScript?
Yeah.
So we got 4 loops and for each possible, yeah. So we know about loops. I want to take a moment here and really stress something that developers have a hard time doing, so the sooner I can tell you this, the better. When you're working in a procedural language like JavaScript, or I'm going to be showing you C# in a week, those are all about iteration, which is looping. Big fancy term for we type a lot of loops. For loops, for each loops, do's, whiles, all those are loops. And that's pretty much the correct thing to do in those languages. You pretty much take a list, you loop over it. If you needed to correlate two lists in some way, you do nested loops. That's the right way to do it in those languages. What happens often, especially if a developer starts in a procedural language, which is pretty much anything except ANSI SQL, most languages are standard looping, standard iteration. They'll come to SQL and they'll start adding loops here. And I'm just going to tell you not to do it. It's possible. I will in a later portion of our presentations. We'll be talking about a few looping constructs. But I want to stress to you that it's probably the wrong idea. And if you feel the urge to do it, please call a friend, ask a mentor, ask a tech lead on your team, confirm that looping is the correct solution, because it's probably not. It's very tempting as a developer when we're used to typing loops all the time. I'll be showing you plenty of loops in a week in C#, just all kinds of loops. And different ways of looping and stuff. When we come to T-SQL, we don't do that. Why? Because this query language is a very powerful, what I call set-based language, right? It's really good at working with sets of data without looping. That is to say, without you typing a loop. It does some looping under the hood when it needs to, but it's really good at doing these sort of things. And I want to tell you that because if you learned a little bit of JavaScript, when you looked at the original data set, your gut might have told you something. It might have said, well, Derek, this is easy. I'll just bring the two customers into some language, maybe JavaScript, maybe even T-SQL. I'll loop through them and then do a select with a where clause of customer ID on all of the phone number values and union those all together. And that would technically work. It would be extraordinarily slower than you think it would compared to what we just saw. I just want to stress to you that when you write in a relational database queries like the one I've written here, they are highly performant in ways that you can't imagine yet. They're really cool. Some of the techniques that use under the hood are amazing, but they are very fast. I will be showing later that there technically is a while keyword in T-SQL. I will show it a little bit, and then I'll tell you never to type it again. That'll be an exaggeration, a little bit, but it's probably wrong. I just want you to separate the two things. Most of the languages that are going to be talked about in the Empower course, you get your JavaScripts. There's going to be some Python, I think. Obviously, I'll be talking about C#. Those are all procedural languages. Loops are fine. In these databases, they're not fine. Okay? Try to keep it to selects, joins, froms, wheres, group bys. Those are all set-based mechanisms, and these softwares are exceedingly powerful at being very efficient with data sets in a way you might not believe. So I want to take that digression and just stress that it's two different mindsets. When you're in T-SQL, don't think about loops ever. Just keep it out of your mind. Wait till you got a few years under your belt, or until a mentor says now is the time to use a loop or a cursor or some other mechanism like that. So I just want to stress that. These joins are much more efficient than they appear to be. It looks like it's not doing much work, but they're really designed pretty well. So there's our rerun with just the data that we wanted, with no loops. All right? Questions about that? All right. So you might be wondering, let's see, query phone numbers. You might be wondering what would have happened if we had a customer with no phone numbers. I'll re-highlight this. This query would have returned the exact same result. If we had customers with no phone numbers, they just wouldn't be here. So if I added a David on here and never gave him a phone number, it would remain 4 rows. All right, this is only an inner join, like I said, a Venn diagram where only when there are matches do rows show up. It's just a list of phone numbers with customers attached. If a customer exists without a phone number, that person's not in this data set. Okay. Now you might want to ask yourself, what about the opposite, Derek? What about a case where the phone number exists, but the customer doesn't? That's actually not possible. It's not possible because of that foreign key. Remember when I tried to insert an ID of 9999, where a customer didn't actually exist, it wouldn't even let me insert the data. Properly designed foreign keys put us in a situation where that illegal sort of layout of the data never becomes true, which is really awesome, actually. It's going to save your bacon many times. A lot of people don't like to see error message on the screen, but I tell you, when you see that one, you're going to love it, because what it means is you made a mistake, but nobody's going to know about it except you. Because it never makes it out to production, never hits customers, and is never a bug. Question?
If I had a null on customer ID there, could I have a phone number without a customer? If customer ID was a nullable field?
Oh, gotcha. So the question is, if this customer ID was null, could I have a phone number without a customer? I believe nulls foreign keys are allowed. I've never designed a database that supported that, but that's probably possible. Yeah, you could have a null, in which case what I just said would be incorrect. You could have a phone number without a customer.
But not the way you've got it.
Not the way I've got it, though. I have a stronger relationship that demands the customer be present. And it's because it says not null right there. It says not null. I guess there are some cases where I might make it null, but unlikely. Is there a question in the back?
What happens if you have a space
Each of the
and
phone numbers
first
is
name
tied to an
instead
ID,
of a name?
and then that ID is tied to the person.
I heard only part of it. A space, something?
So instead of the name Bob, what if you just have a space as your character?
Okay. So the question is, what if instead of a name like Bob or Alice in the customers table, what if the actual name was a space? Everything would still work the same. But when you got this record set back, if that customer had a phone number, it's going to be, it would be a space here as well. That's true. Hopefully you would not have names that were white space only. That indicates usually a boo-boo more than anything. It really wouldn't make sense to have empty space for first name unless it was really optional. But in such a case, I'd prefer a null. Questions at all about that kind of join? We will be talking about others.
Winston-Salem says, can you give an example of using a null?
For what?
I'm not sure. Let's see.
Maybe they want you to show the, what we were just talking about.
About nulling the customer ID? Let's confirm if that's what they want.
Yeah.
Give me just a second. I'm going to make sure I know exactly where I am in my notes. Join predicates, Venn diagrams, missing phone numbers.
I think it may have been, you said I would prefer a null instead of a space. You were just saying, what does that mean? Unfortunately, I don't think any of your fields are not null like a good database design is.
You hear the compliment, yes. Yeah, I don't do nulls unless I actually need to.
Yeah.
I could add a column here and do nulls, but I feel like we sort of covered that. So in order to try to get out of that request, I will basically point out that, with the exception of the comment about nulling the foreign key, any sort of nulling on here would work the same. Joins don't change the way other columns that are not participating in the join operate. So if I did have another field on customer, like age, but we made that optional, right? So that's nullable int. I could put that here. It won't work right now, so don't follow me. This will be red. That would be null when it was supposed to be null, and it wouldn't be when it's not supposed to be. It would be nothing different than what we saw earlier this morning. It doesn't fundamentally change the joins. Gotcha. Had to figure out if I was going to cover left yet, but not yet. I do want to add one thing just to sort of fully elucidate this. I'm going to go to the phone number table. I'm going to add a flag to it. Oops. If I do it correctly. Flag, another term for a bit, which is another term for a boolean. People often call them flags, especially DBAs. We're going to flag that record, inactive or something like that. So I'm going to go in there. I'm going to add a flag is textable. I have to leave it null. Although I don't want it to be null, right, because I want it to be a true false, I have to leave it null, and the reason is I already have data in this table. Right, it's going to complain to me because the designer doesn't know what values it should put in, and it doesn't want to guess on my behalf, which is good. You might think you might want it to default to false, but that's not necessarily true. Your boss might have wanted you to default as a true, so you wouldn't want to rely on the software to take a guess. So we're going to leave it nullable. So we'll look at the whole record set. There's our is textable flag. But let's clean this up. And you'll be doing techniques, you'll have little tricks like this. This is one way to solve a problem. We added the column, but let's say it's actually really bad for it to be null. What we can do is we can decide. Our boss can say, well, let's just, in order not to spam people's phones, let's make it default everybody to being not textable. Well, we talked about how to do update statements earlier today. So let's fix this. We're going to change all of them. So let's update phone number. We're going to set is textable, and it won't be in the drop down because I haven't refreshed, equal to 0. Now I have left out the where clause. Remember I told you to be careful of that, but in this case that's actually what I want to do. I actually do want to go ahead and get all the nulls set to false. I can run that. I'll get 4 rows affected. We will confirm the data set. Is textable is no longer null. They're all zeros. That's beautiful. Now I can go into the phone number table and actually make it not nullable. Right? Because at the moment it's actually true that none of them are null. This will be a safe save. I hope it'll let me save. It'll give me a warning, but I'll say sure, no problem. And there we go. If I refresh the columns, on the left, we have an X textable, it's not null. So you'll encounter stuff like this a lot as a developer in many different ways. And there's more than one way to fix it, but generally the most common pattern, if you need to add a non-nullable field, is you have to first add it as nullable, get all the nulls out of the way, and then officially make it not nullable, which is what you saw me do here. It's a 3-step process. I added it as null, they were all nulls, I set them all to 0, and now I could make it not null across the whole table. I couldn't make it not null at the beginning because it didn't know to put zeros in, so I had to do that work in a 3-step process. There'll be a lot of techniques like this you'll learn along the way, where we have little tricks for migrating schema as we go forward with databases. We're always adding columns and removing columns and adding tables and removing tables. How do you do that safely? How do you do that in a situation where it's supposed to be non-nullable in the end, like I just showed you now? There will be tricks, and they're usually multi-step processes that themselves are pretty straightforward. Add it nullable, set all to 0, not nullable. 3 simple steps, but you got to do them all in order to end up at the last step. If there's any data in the table, you got to follow those 3 steps, or some similar process. So now that I've got that there, we did that so I could point out something. So let's I'm actually going to make one of them textable, otherwise the example falls on its face. So let me update phone number and set is textable equal to 1. I need a where clause. We'll say where phone number ID is, I'll pick number 3. Actually, no, I won't. I'm going to pick number 2. I'm going to pick one of Bob's numbers. So I run that. I get 1 row affected. As always, we'll confirm by looking at the data set. There we go. Oops, I meant to type number 2 there, but that's fine. It's still one of Bob's phone numbers. That first one is textable. See, the flag is true. It's true, false, false, false. The reason I did all that is we go back to our original join. So let's look at that data. It was our 4 rows. Remember, they wanted phone number, customer first name, customer ID. I can put where clauses. Joins don't stop you from doing any sort of where clauses or group bys or any of those functions we talked about. They just add to the equation. They make a table kind of look wider by attaching it to other tables. In this case, we did it with an inner join. So I can do a where like anything else. I can do where p dot, it's not on the list, but it is textable, equals false. And now we should only get 3 records back, because remember, one of Bob's I made textable. So these are all the people who are not textable. We'll get 3. Only 2 of Bob's came back. All I'm showing you here is the where clauses you learned about earlier today are in no way precluded by the joins. The joins are just making the from look fatter, look wider, have other data attached to it. But you can put your where clause, you can do all sorts of things with it. In fact, let's make it more complicated. I'm going to say and customer dot, I think last name will be a good example. Let me double check that. No, I have to do first name. Apologize. I'll make it Bob. Now remember, I'm not doing it on Bob's customer ID. So this would be all Bob's in the world, all of their phone numbers that were not textable. And there are a lot of Bobs in the world. It's a very common name. Oops, I ran all of them. Let's just run the one I care about. And we're down to 2. We excluded Alice. So although she's not textable on her one number, she's excluded because of the first name predicate in that where clause. So you'll notice we're combining a lot we've already learned today, right? We've got a select statement for reading. We know how to read from tables. We just learned joins. We learned wheres a few hours ago, but all of these can be mashed together. That's why when I commented earlier that some of us have worked on T-SQL store procedures and scripts that are 1,000 lines long or longer, they're just lots of this compacted on each other. It's just all keep adding. Any questions about what I've shown you so far? Be sure to ask them now because it's almost exercise time, which will go kind of long on, we'll call it a break at the same time since it's about 2:30. Any questions about joins like I just showed? Yes?
Once again, what was this type of join code?
This is an inner join. So I'm actually put that on the screen. That's a good question. The question was, what kind of join is this? If you see it, we run it, it is the same thing. The most common joins done by developers are inner joins, so they don't actually force you to type that. There are other joins we're going to learn about later, which do require more words in front of the word join. But the 2 I just ran were synonyms. That's a synonym. I didn't change anything with that word inner. But we will see other synonyms later, once we have another exercise. Any other questions about joins? All right, let me look at my description for the next exercise. You might want to get ready to type for Winston-Salem Harbor.
Yeah, and Allie said that right before break, after you do the exercise, like he wants to switch real quick and just add a couple things, then we'll break.
Okay, so we'll do the exercise. He wants to talk and then break.
Mm-hmm.
Okay. All right. Be about 20 minutes out. Okay. So you can either do this in the existing database we have or create a new one. We do want a customers table with just a couple names on it, no big deal. But I want you to add a to-do items table. All right. Every customer has a list of to-do items, but there's only one to-do items table. It should store a task name, a priority number, and a completion date. Now, obviously, tasks might not necessarily be completed, so that's got to be nullable.
I'm going to write this out after you, like we can look at it and stuff. So go ahead and say it. And
Okay.
I'll put it.
Gotcha. No problem. We'll make sure it's typed as well as we can. That's a good idea. Go ahead and insert some data, so that some meaningful data, make some of the items complete and so on. And then write some queries that make sense to you. I'm going to give you some examples of what I would probably like to see if it were a real product. List all incomplete items for a single customer ID ordered by priority ascending. That's a long sentence, right? All incomplete items, single customer, ordered by priority ascending. Right? Because they might have lots of different priorities and they want it. This would be basically what would show on the UI. Show me all of my items with my top priority at the top of the list. But only the items I've not completed. Don't show me things I've already done. And if you think about it, that would make sense on a UI, right? That's a very sensible thing to do. Write a statement that marks a single item completed. So that's a different query. Play around with that. Create a report of all customers that have at least one incomplete item. That one's going to be tougher. If you don't get that one, don't worry. Delete all items completed over a week ago for a given customer ID. This is basically a purge button given to the customer so that old completed items can be wiped out of their history. That'll be good enough. And we will get that typed out in just a moment. So yeah, do that yourself. Create at least those 2 tables in a new database, or you can reuse the customer table here
and we should be good.
And we'll post that full assignment in Slack in just a minute.
Yep, that'll be on Slack soon. You want me to keep the stream running?
Go ahead and hit stop because they're going to stream our way.
Richmond, let us know when you got me. Richmond, let us know when you got me.
Can you shut that up?
Richmond, got me. My bad. That was my own fault, sorry. Okay, I guess they heard me. So, let's recap what Derek just went over. And I'm going to fill in some of the things that he went over very quickly.
Wait, give me 1 second. Okay.
Okay. So, it's always good to hear things from multiple perspectives, and let me give you the lightning round. As a professional developer, create a new database. I'm going to do this from scratch. So he just gave you an exercise. So let's go. I'm going to call mine test. Bang, I've got a brand new database. You know, a database is just nothing more than a big bag of tables. By now you know that. And each table, think about a table as a rectangle. A rectangle is as wide as the number of columns. So the columns are the width. And the depth, how long it is what? Rows. So if you have no rows in there, you just have a wide container with nothing in it. But as you add more rows, it gets really, really long. Okay? Think about tables like that. So that's why oftentimes when you draw it on the board, and I'm going to do that in just a second, I draw them with little rectangles because that's the way I think about them. Okay? So now I've got no query windows open. Okay. Here is in the real world how you create tables. You can use Designer, but it's actually painful for me to watch somebody use the Designer. Create table, dbo.customer. Now, you know what are the column names? We're creating the width. So let's create, I'm going to create a primary key. We're going to go over what a primary key is real quick. Most often, just name it ID. It's called a surrogate key because the whole point of a primary key is that it identifies uniquely. This is what it does in life. It uniquely identifies one row in that table. That's what it does. That's why it's called primary key. Okay? Most often, it's just an int, just an integer.
What's DBO?
Okay. DBO, in SQL Server, and I think Derek's actually going to cover this a little bit later, DBO, in SQL Server, every table has an owner. By default in SQL Server, the owner is a DBO context. So it's the default. I don't have to put that in there. It's going to do the same thing because DBO is default. So, ID int. Now, I want this to be that auto number feature. And actually in MySQL and PostgreSQL, they call it auto number. How do you say that in SQL Server? Identity. Can a primary key be nullable? No, it can't. Because it's going to uniquely identify one row. And it wouldn't make sense for it. And we're going to talk about what null means. Does anybody catch what null is? The absence of a value. Conceptually, that's all it is. So why do you have it? Well, sometimes you want to say, I explicitly have an absence of a value for this column, for this row. That's why you might use it. Question?
How do you get to the string without, oh, that's
I just said new query.
Control N.
Control N does a new window. Learn something every day. So, not null, primary key. So that's a mouthful right there. You don't have to memorize that. But you know what? It's going to become second nature. Database people tend to be shy of writing code because they're used to dealing with nice little applications like this. You're developers. You can write scripts. Relax. It's just code. And actually, you're writing one language. Just one. All relational databases speak SQL. So just learn this one language, and it's transferable. It's a valuable skill. So this is DML or DDL? Data definition language or data manipulation language? Which one is it? DDL, because I'm defining the table. That's the difference. If I'm creating structure or changing structure of my tables or something else in the database, then it's DDL, data definition language. You're defining the containers. DML is when you're dealing with the data in those containers, data manipulation language. Okay? So I'm just going to have one column, just to keep it simple. Would this be good or bad? Well, it's going to be bad for a couple reasons. Wouldn't it be easier to just do that? Just, why have a first name and a last name? You know, it's kind of a drag to have to create columns all the time.
So you can identify, and you identify, well, no, I guess that'd be the idea.
I'll show you why it's a bad idea. So I'm going to run this, bang. I have a table. Wouldn't that quicker than going and using the designer and typing in, like, where's that little button? Screw the button. You don't need the button. You just need a script. So insert into customer. What do I need? I need one column. Values. I got a row. Proof. Now, if I want to add 3 more, I'm going to add myself again. Okay. So I've got 3. Once again, remember your typing skills. Remember your keyboard skills. Learn to leave this aside. Don't use your mouse. It slows you down. You want to set yourself apart from other developers? Do it faster than they can.
Add yourself again by accident, then show them how to delete it, and then show them how the ID actually does not get reused.
Okay, so Ballant is having a special request here. He says, oh, by the way, add yourself as a duplicate. And then, you know, I'm going to add a few duplicates. I'm going to run that again. So I've got a bunch of duplicates now. Let's take a look. I've got a whole bunch of names and I've got a whole bunch of duplicate people, but you know what saved me? My primary key. That's why we have primary keys, so I can uniquely identify one row. Remember in ID in CSS and in jQuery? Same concept. The reason you have an ID is so you can talk about one specific thing. In the context of databases in SQL, we're talking about one row. So if I want to get rid of all the duplicates, pretty much everything after ID of 4, how do you do that? You've seen it once or twice, and I know I'm asking a lot, but can anybody wager a guess? Remember your conditionals from JavaScript? Pretty much the same things work here in SQL. ID greater than equal to what? 4. I'm going fast in the editor here, but how am I moving around? I've got multiple queries here. And this is DDL, this is an insert, this is a select. I'm going to run a delete. If I pressed F5, I would make a huge mess, okay? So if you're not comfortable selecting, it's very important that you select what lines you want to run. If you're not comfortable, it doesn't cost you much to click New Query, okay? New Query and just press F5, it runs everything in your window. Be careful that you select exactly what you want, because I myself have made many a time mistake. I thought I had that selected, and all of a sudden there's a huge delete statement or an update statement I didn't mean to run again. Okay, so I just deleted that. How did I delete it? Because I had a primary key. That's why primary keys are important. Now, if I wanted to have, say you're doing this on the job, and we thought we're going to be lazy and we're going to create one column rather than 2 columns, name column. And 2 weeks later, you realize why this is a bad idea. Your boss comes to you and says, you know, we need to send out a postcard to our customers and say this is the customers table, and we just need their last name on the last line. Go put that together for me. We're going to do a word mail merge. Uh-oh. How do I get just the last name?
Let's do like a string parse.
It's not going to be perfect. What about those, Brendan's name, for instance, Devet? What about the people who have no middle name? You can't, and people's names, sometimes it's last name, comma, first name. It's a mess. And some people from Southeast Asia, I couldn't tell what's their first and what's their last name. So to answer your question, to answer your boss, like, I screwed up, we don't have that data. We don't have that information. Don't do that. This is called, dipping into academia, first normal form. That means anything that can possibly be used on its own should have its own column. Doesn't matter how pedantic it feels. Always create a column for the most granular data you can ever, in your wildest dreams, imagine. I might want to use that by itself. Because if you do that, you know what? I'm going to show you how quick and easy SQL is. Here's how you delete an entire table and all of that data in it. And that's how easy and how dangerous it is. It's gone. I have no tables anymore. You know what? That's not a problem because I know scripts that can create tables really quickly. What's the syntax here? Remember, you're just learning one more language. Comma in between your columns. You specify the name, the type, and, you know, that's even optional. What do you think the default is? Nullable or not nullable? Nullable. So it's nice to say not null if you don't want to allow nulls. That's it. There's no crazy syntax, okay? And this foreign key thing that Derek unfortunately fumbled with for like half an hour and I need to have that little button up there and I'm going to relate this to that table. I'll show you how to do that in like a second. Nothing, I know Derek's probably there, great. You know, he's talking bad about it. No, I'm not talking bad about you because he did it the right way that most people in the world use. I'm showing you the way that professional developers that do this every day as development do it another way. So here, create a table. I've got my customer table back. I think, yep, command completed successfully. I'm going to insert this, and it's going to complain. What's it going to tell me? Error messages are your friends, just like Derek said. I don't know what you're talking about. SQL messages are very, very helpful. It says, I don't know what you're talking about. Invalid column name. That's because it doesn't exist anymore. And how do you specify multiple columns? First name, comma, last name. It's really simple. Now, I'm going to add that. Okay, so we created a table. We added data to it. We selected data from it. We decided, oh, that was wrong. We dropped it. We recreated it. We added a few records to it. It's that quick. You make a mistake, you get a red error message. It tells you exactly what the problem is. You're starting to see the immediate gratification here. So now, boss comes to us and says, you know, I like the last name, but I really want to have their full name in the title when it says Dear Sarah Tahbaz. Here's why we did it the right way this time. He taught you about aliases for tables. You can have aliases for columns. How do you concatenate in JavaScript? A plus. How do you concatenate in SQL? A plus. You're starting to see the patterns here. There's an optional keyword called as. As is like being verbose, like, oh, I want this as that. I want to name it that, is what you're saying. You don't have to say it. It's less readable to do it like that, but you can say it like that. So you might see it in the wild. As is an optional keyword. Personally, I always say as when I'm renaming a column, but I never say as when I'm renaming a table. So like that. You can easily say as C. Same thing. What you're doing is saying, I want to give it that name as an alias, a nickname. So why is it complaining? Because I've got a comma, and I said I wanted their full name and I want their last name. It's no problem at all to put things back together. It is a huge problem to try to break them apart. There are substring functions, and to Scott's point, well, you could do some string parsing, but how do you know where to break it up? It's all just one jumble of text. And that's the line between developer and user. You don't want to guess about their data. That's their thing. So, just taking some notes. So that is first normal form. That means always define your columns in as granular a format as you can. Foreign key. So I've got a customer. What about phone numbers? Let's do that. Somebody tell me the syntax for how do you create a phone number table. It's very simply create table. Name of the table. What are we going to call it? Phone number. Just call it phone number. Open paren means I'm going to start my table list of columns. What do we have in our phone number table? We need to have a primary key again. Why? Why do we care about primary keys? Uniquely identify one phone number, one record, in case we ever want to update or delete it, or even select it. So we're going to have an ID. Just call it ID. You can call it phone number ID, but I don't like to type, so I just call it ID.
Can that be confusing though? So once you get multiple tables and start doing joins, just having ID can...
We always know.
Whenever you do joins, we're going to actually join in a minute, you always have to specify which table owns that column. So you always have at least an alias. So if I had an alias on a phone number table called P, it's going to be P.ID.
Gotcha.
So it's pretty clear from reading the query. Okay. Following Derek's suggestion, we're going to put the... Oh, sorry. The question was... actually, I don't remember the question. What was the question?
Doesn't it get confusing if all of them have the column name?
Yeah, the question was, isn't it a bad idea to name it ID because you have an ID on the phone number, you also have an ID up here on customer. How do you tell them apart? Whenever you're talking about more than one tables, you always prefix the column names with the table name or an alias for that table name. So we're going to write a join and inner join like Derek just did, and that's really the exercise here. And you're going to see that whenever you're doing joins and talk about more than one table, you always prefix it by the owner. So it's going to be obvious. So phone number, what do we need in here? I'm just going to call phone number... I'm going to choose varchar, and Derek is concerned about performance. He's right. A big int, just a number, is stored smaller on disk. But in the real world, what happens about extensions? A lot of people have extensions, and they have like a little X. If you didn't make it a string, you couldn't put the X in there, because an X is not a number. And you never want your database slowing you down. I'm sorry, Derek, real world. It's like, let me store the data I need to store. And he's probably going to say, well, you could add another column that has it. Okay, yeah, you could. He's going to be able to rebut this, but this is the way I would normally do it. So phone number, varchar 25, that allows me to put the little parens in there, the hyphens. I can put 2 spaces before the extension, an X, whatever they want. It's a string. I really don't care. I just want them to be able to store what they need to store. So is this going to be nullable or not nullable? What do you think, Aaron? Not null. What does that mean? That means they have to have a value. Does it mean it has to be a number, a valid phone number? No. It could be a blank, but it has to have something. So that's not going to work as is because, as Derek said, these are going to be isolated tables. There's nothing that connects them. Imagine one spreadsheet and we had first name, last name, and we had the phone number there. That wouldn't work because, based on his example, add secondary, tertiary, quaternary phone number, it gets really verbose. Why do we do that? And the answer was, somebody asked that during the session, why not just add columns to the table? Because you have to change the database structure. That's developer work. We don't like to work when we don't have to. If you design your database well, let the users add rows. You don't have to change the structure whenever somebody needs something new. So technically, I believe that's second normal form. Don't worry about that stuff. All we're saying is that you want to design your database so you don't have to change the structure to accommodate more data. You just want it to happen. Because when you change the database structure, guess what? You have to change your application code that talks to your database too. It has a domino effect. So we don't want to do any of that. We want to build the database so it's right from the start as much as we can. So how do we relate the phone number? So we're taking the phone number off. And I don't know if you all can see me up here. See if you can... actually, you all back there at the back TV. Tell me if you can see the board.
Yeah, bring it down a little bit.
The other way?
That's up.
Yeah, close forward, no, towards you, down. Close
Yeah,
forward.
close it.
Close.
You got a lag, so...
There you go.
Okay. Okay. So we've got... so originally we had this. So you're asking yourself, we've got a customer table, and you got a first name, got a last name, and you've got a phone. Okay? So life is simple. Life is good. We got one table, throw all your data in it. But we're planning ahead, just like Derek taught us to. So what are we going to do instead? We're going to break this off, and we're going to take it and put it somewhere else. We're going to put it into a phone number table. And I'm just recapping exactly what he did. Now, in a simple world, if things worked as simply as we could, we would just say phone. We're good, right? No. Here's where the overhead and relational design comes in. If you put a table together that's separate, it needs to have a primary key, number one. Why? So that we can talk about one individual row later on. So we have an ID field. Okay? Now, we're all well and good, but think about it again. We broke this phone number off of this table, and we put it over here. How do we remember that this phone number belonged to that record? We have to have something to connect them back. That's what's called a foreign key. So that's what this is, customer ID. Customer ID. Okay? So this, the whole purpose of this is complete overhead. This is to link it back to that. It's what he was talking about. Children point to their parents. This is the pointer. So we have our real data right here. That's really all we cared about to begin with. When you break it off, though, you have overhead, because this is the primary key for this table, so we can uniquely delete one phone number in the future if we want to. We need this one because we need to relate it back to where it came from. So Bob Smith, I think, or whatever it was, Bob has 3 phone numbers. If we didn't have this, we wouldn't know which phone number went with Bob. Now, how do you do that technically? Each one of these, I didn't even write the primary key over here. So we have an ID over here. So that customer ID actually goes specifically to that column. Normally you don't write the columns, so you just write the tables. And it's like, okay. And by the way, and I know he's going to get to this, so I'm stealing a little of your thunder again. Sorry, Derek. 1 circle means 1. 2 circle means many. 1 to many. Why is this 1 to many? Somebody explain that to me.
One customer, many phone numbers.
One customer can have many phone numbers. Okay? Good. Sometimes it helps to understand visually what we're doing and why we're doing the columns. Now, technically, let's do it in code. So, we've got, by the way, if you have your results and you want them to go away, Control R toggles it. So, let's go back to, what have we got? I forgot what records we have. So the question was, how do we get the line numbers so we can actually talk about things? And I hadn't actually run that because I hadn't actually had the foreign key, but let's do the line numbers first. So the question was, how do you get your line numbers in your SQL editor? That's over here. Tools, options, text editor, all languages, line numbers. Okay, so if I ran this table, it's going to be wrong. What am I missing? Creating the phone number table, it's going to be fine, you think, but we have an ID, we have a phone number, what are we missing? We're missing our foreign key. This is the thing where the designer is so much more painful, and I don't think Derek uses it either, because, oh, I've never even seen this user interface. So yeah, let's not show it to you. So here is, how do we create a foreign key to another table? Let me get rid of this stuff. So this is the table up there. Create a, what's the name of the column? We're just say, let's call it customer ID. It's got to be the same data type, int. So we're connecting customer ID to the primary key ID in the customer table. Not null, because we don't want to have null values. Foreign key, references. What are we referencing? It's almost like speaking English. So foreign key references customer parentheses ID. Bang. It's not that hard. Don't be afraid of it. It works. And with that script, not only have we done it once easily and quickly, we've made it transportable. If I wanted to send a table to Harper, I don't have to bother with SQL Server Management Studio. I send him this script, he knows, number one, exactly what I meant, and he can run the script, and he can create the table for him immediately. This is the parlance of how you speak in database language. So, now that we've got phone number, we've got nothing in there. We've got some customers, but no phone numbers. How do you join these things together? you've got to use, this is where the weird technical nonsense comes in. The primary key, 1, 2, 3, must be referenced from here. So we've got to have the number in our foreign key column match our number in our primary key column. So how do we do that? Let's create a phone number. Let's create a phone number for me. Phone number. And what are the columns in my phone number table? It's phone number. Now, we didn't specify ID. Why not?
Because it does it automatically.
The ID is an identity column, which means it's automatically assigned. We can't even assign it if we want to unless we have a special command to override that. So we're going to insert the phone number, and we just kind of ignore it, and it'll take care of itself. So customer ID. So what are the values? If I want to add my phone number, say it's going to be all 5s like they did in the late 80s. Values. It's a string. 336. 5, 5. I think there's even a song about it, isn't it? 555. Yeah, 86709 or something. 7, something like that. Anyway, so I don't have a singing career either, we did. So customer ID, it's mine. So what are we putting here for a foreign key? 3. Does everyone understand why we put 3 in there? Because this is, right here is the results. These are all my customers. 3 is my primary key. That's the ID value for that row. Remember rectangles. So the width, and it's actually on the screen as a rectangle. ID, first name, last name. That's the width of my table. Which table? This is customer. The length, this is rows. So the third row, the ID is 3. So insert into phone number. I'm going to say this is my second table. It's got 3 columns, ID, phone number, and customer ID. So you don't worry about ID, it takes care of itself. Phone number is just whatever value it's going to be. And then this is the all-important, how do you link it back? This is this little line from the phone number table to customer. This is how you connect customer to all the phone numbers. So I can have multiple phone numbers if I want. So let's go ahead and run that. 1 row. Now, those are 2 queries. Now, I want to build, we're learning about joins, and once again, I told you this is a lightning recap, and it's just that. I've got like one more thing, and then we're done. So, I want to say, give me all the data. I've got 2 tables, customer and phone number, and they're linked together with customer ID. How do we link them together? You just saw this like 10 seconds ago, so I don't expect you to have memorized it. Select. I always write my selects out, just the structure. Kind of like your HTML page, you got a structure to your select. It's select, columns, from, tables, and then you usually have where, which is a filter on the rows. So the select says which columns, you're making your width smaller. The where clause makes your length smaller. From is where do you want to get your data from? So, customer, that's an alias. C is an alias for customer. How do we talk about another table? How do you join them? It's actually just the inner join keyword. There are not a lot of joins. Contrary to what you just heard, there's like 3 joins that you really use, and there's like 5 total in the world. So don't worry about it. It's not that big a deal, and we're going to cover every one of them. There's an inner. He's going to cover, I'm not going to steal his thunder there. So inner join is what we know now. So customer, inner join, that means you have to have a match. Phone number. How do we join them? I mean, you have to specify the column in each one. That's the whole point of the alias here. And it's, you know, I'm going to turn off my IntelliSense in a minute because it does nothing but bother me. Select, it's saying, oh, you haven't specified any columns to come back. Okay, I really don't care what columns I come back with. So, and I think I showed this to you earlier, but here's a quick way. You can drag and drop the columns and it'll list the columns from that table. It's usually customers usually don't care, and users don't care about seeing your keys. So really, let's just give them what Derek called the fluff fields. First name, last name, phone number. So getting back to our idealistic world, we just put it all in one table. You can make it look like that. That's what you got to think like. You're going to do it right in the database, but how you expose it to the rest of the world is completely up to them. It's up to you. So you've got first name, last name, phone number, customer inner join, phone number. What do we join it on? Primary key to foreign key. What are they? Right. That's going to give us, you're going to see something strange here. And that's really the point. If we run this, we only get my name back. Because an inner join says you must have a match, no exceptions. And even though we have 3 customers, they don't have any phone numbers. You get it? So joining is another way to actually implicitly filter data. You got to be careful about that. What happens if I had 2 phone numbers? And let's do that. How do you add a phone number? What did I call it? Probably just phone number. Yeah. You can actually drag and drop column names too. This is why Derek would quarrel that I shouldn't allow strings for phone numbers. Nonsense phone. Database can be perfectly all right with that. And customer ID, I think I was a 3, wasn't I? Let's see.
Yeah.
Yeah, on customer ID 3 down here. Now, the join is going to come back with what? It's going to list me twice. That's the nuance of an inner join. This is the most common join. I'd say 80% of the joins out there, inner joins. You're just putting tables back together for presentation. And I'm done for now. Questions? And let you go do your exercise.
How would you use like brackets instead of squares? Like with phone number, you have brackets.
Okay, the question is, what are the square braces for? Brackets used for instead of the parentheses. Brackets are not necessary, but if I had, there's actually, unfortunately, in the South they say, bless your heart, when they like taking benevolent pity on somebody. That's sometimes how we feel about other database designers. They did that, which they put a hash as part of their name. Don't ever do that. Don't ever use special characters in your column names. It will let you do it. All you have to do is put a square bracket around it, and SQL will figure it out. Why shouldn't you do that? Because, number one, it's hard to look at. It's like, what is that? Oh, that's part of the column name. And if I'd left this off, that fails entirely. So you're requiring every developer behind you for the end of time to have to put special characters around your special bless your heart column name. Don't do that. If you put spaces in your column names, same thing. They have to put a square bracket so that it can be parsed as one name. That's why. The paren is actually part of SQL syntax. The rest isn't.
And the small c, the keys, are they referenced in the columns?
So right here, this is, so the question was, the small c, are they referencing columns? No. It's kind of backwards how the aliasing works. And I really got to turn off my IntelliSense because it says everything's wrong, but it's actually not. Okay. Control-Shift-R is the shortcut that I just did to make IntelliSense catch up. What it was, I created those tables and IntelliSense hadn't caught up with reality. I told it, catch up, Control-Shift-R. And it says, okay, I'll go figure out reality now. So now you have no more squigglies. So, answer the question. Table aliases work a little bit strangely. The first time you reference the table in the query is when you give it the alias. Now, I'm already talking about the alias up here, c dot first name, but that's because you don't ever talk about a table until the from. So this is the first opportunity I had to give it an alias. So you have to kind of read the query in its entirety before you can really understand what's going on. So the first time I mentioned customer, I said customer, and I could say this, as C, and phone number, the first time I talk about it, as P. From then on, both in the select and in my on clause, I can use those aliases. So up here, C.firstname means customer.firstname. Over here, this means phone number.phone number. That's all that means. Any other questions?
Can you say that again? Why do you have to have the little p?
So the question is, why do I have to have the little p? I don't, actually. I could name it, I can name it whatever I want. It's an alias that allows me to avoid typing. If I didn't do that, I would have to do this. I don't have to have an alias, but you'll see it as common practice because people don't like to look at that. It's just more verbose. A lot more typing. It's kind of like a variable, but it allows you to, it's called an alias just because it allows you to say, instead of having to type the whole name, I'm going to give it a nickname. That's all it is.
So are you defining it in the select?
No, I'm using it in the select. You define it the first time you reference the table. Because I haven't talked about the tables up here. I talked about the tables in the from clause. So the basic structure is select, column list. That's not SQL. That's that squiggly brace, that curly brace. That's my own syntax. From, table list. Table and joins. Then if you want, you can have a where clause, conditionals. And he's going to talk about 2 or 3 other little clauses. Does it matter if I put it all in one line like that? It'll work. Just be careful to make it readable. Does it matter if I want to leave off the inner because it's the default and write it like that? It doesn't matter. It's all good.
Yeah, I would use greater than or less than because if somebody copies that down, they're going to think that there's brackets and parentheses that go in the syntax.
Yeah, I don't want to mislead you. That's not valid syntax. I'm just trying to show you. Right now, we've learned 3 SQL keywords: select, column list, and we learned star. That means all the columns. They're down. Okay.
How important is it to capitalize the select from?
Not at all.
Not at all.
That works just as well. It's not case sensitive.
Is it just like best practice, I guess? Like if you go somewhere and you type it all in lowercase, is someone going to be like, you idiot?
No. It's I'm hesitating because it's more a holy war type thing. Like Derek has worked in organizations that are. When I was shaking my head when he said they were discussing the pros and cons of putting this table before that table in an inner join. I was like, oh my goodness! If I were speaking about that for more than 5 seconds, I would have to shoot myself in the head. It's like, it does not matter, okay? At all. If they had an hour conversation, I would leave the company. It's like, let me go do something worthwhile, okay? There is absolutely no difference. None.
Okay, cool.
So, syntax like this, from, doesn't matter. I can read from like this just as well as I can read from uppercase. Now, in his organization, where he's worked before, they would probably have a little talk with him and have a half-hour meeting. It's like, you didn't capitalize your from. It's like, okay, that's why I don't work in that organization. At Sightsource, it does not matter. Any other questions? Okay. I think Harper has pasted the exercise over in Slack, or Derek has written into Slack. Go do it. And then if you have questions, call us over.